Okay, so today I am doing a lesson on systems of equations, which is what you are learning about this week, and does have one question on the final exam covering this, so it is important to learn it unless you just plan on automatically losing a question, which I don't recommend doing. So we're going through section 6.1 and 6.2. So 6.1 and 6.2 cover using the method of substitution to solve systems of linear and nonlinear equations in two variables. I'm sorry if you can hear my dog barking. She is very unhappy right now. Using a graphing method to solve systems of equations in two variables. Using the method of elimination to solve systems of, that's supposed to say of, typo there, of linear equations in two variables, interpreting graphically the numbers of solutions of systems of linear equations in two variables, and using systems of equations to model and solve real-life problems. So I'm going to focus on substitution and elimination in this lesson. So first we need to start with a system. What is a system? So a system is a set of two or more equations. So here I have an example. This is a system. We have two equations written above each other, and then we have this curly brace. This curly brace is required to indicate it's a system, and so it indicates that they need to be taken together. So it indicates a system where these are considered together. So that is a requirement. The solution to a system. So normally when you solve an equation, you have one variable, your solution is one number. Here we are going to have two variables, so our solution is going to be an ordered pair of x and y. So if you have two equations with two variables, let's say they're lines, then they're going to intersect somewhere. So your solution represents the intersection of the equations when you look at it graphically. So there are basically, let's say I look at these with lines. This is one solution because there's only one intersection point. It is possible to have more than one solution if you have a nonlinear system. So let's say we have a line and then a parabola. This would have two solutions because there are two intersection points. So a system may have more than one solution depending on what the equations are. It is possible to have no solutions or infinite solutions as well, and we'll see that later. So we're going to start with the method of substitution. This is usually the preferred method for most students until they start working more with systems, and then I find they usually transition to the other methods. So there are essentially 5 steps here. Your first step is to solve one of the equations for one variable in terms of the other. So you pick an equation and you solve for y or solve for x, whichever is easiest. Step 2 is to substitute the expression found in step 1 into the other equation to obtain an equation in one variable. So that's the substitution step. Then you solve the equation you got in step 2. Then you do what is called back substitution. So you back substitute the value obtained in step 3 into the expression obtained in step 1. So you take your answer from solving and you plug it into the equation that you started with. And that will give you the other variable. And then you check your solutions to make sure that it actually works. And you'd have to check your solution in both equations to make sure that it is indeed a point in both on both equations or on both. So I'm going to do all of these examples with linear systems because that is the most common type of system you'll see. So I'm starting here. I have two equations. These are both linear. These are in mx plus b form, so this is slope-intercept form. When they are already solved for y, the substitution step is really easy. So I'm going to just note that we're going to be doing substitution. So they're both equal to y, and the solution is where they have the same ordered pair where they intersect, so their y values must be the same. So that means these two y's must be equal to each other. So that means you can set the equations equal to each other. So you have 10x minus 2 equals negative 2x plus 6. So Because they're both solved for y, you can set them equal to each other. And then we have an equation that we can solve for x. So I'm going to start by adding 2x to both sides. And that gives me 12x minus 2 equals 6. Then I will add 2 to both sides. And that gives me 12x equals 8. And then I divide both sides by 12, and I'm going to get a fraction which I will reduce. I can divide those both by 4, and I get 2/3. Now here's the thing, your answer is an ordered pair, so you're not done once you solve for x, because you still need to find y. So I'm going to do this in a different color, and I'm going to just take the first equation. We have y equals 10x. So x is 2/3, so I'm going to replace x with 2/3. So I have 10 times 2/3 minus 2. So I'm solving for y, so that would give me 20/3 when I multiply minus 2. I need to get a common denominator, so I have 20/3, and that would be 2 over 1, and I have to multiply it by 3. So that'd be 6 over 3. And then when I subtract, 20 minus 6 is 14, so I get 14 over 3. So now that's my y value. So your answer is an ordered pair x comma y. So my answer is 2/3 and 14/3. And so that is the solution. So you can check this by plugging this back into the equation, or you can also check it by graphing. So I'm going to bring up Desmos. Let's start graphing. And I'm going to put, so I've got 10x minus 2 and negative 2x plus 6. So y equals 10x minus 2 and y equals negative 2x plus 6. Okay, so you can see that they intersect. And then I'm going to look at that intersection point, and it says it's 0.667, that's 2/3, and 4.667, which is 14/3, is rounded. So the point where they intersect matches with my answers. My answer is exact, this is rounded, and so that means you've done it correctly. Now let's take a look at example 2. So I solve the following system. I have y equals 2x plus 5 and 2y equals 4x plus 10. So I have one equation solved for y. So everywhere I see y in the second equation, I can replace it with the first equation, which is 2x plus 5, because y is equal to 2x plus 5. So I have 2 times y, and y is equal to 2x plus 5. And then my right side is 4x plus 10. So I'm putting the first equation into the second equation. Now I need to solve for x. So I'm going to distribute on the left side. So I'm multiplying 2 through the parentheses. I get 4x plus 10 equals 4x plus 10. Now I have the same thing on the left side and the right side. If you remember from week 2 where we talked about different types of equations, this is an identity equation because both sides are identical. An identity equation, if you remember, the solution is all real numbers. So that means it doesn't matter what x is, and we can double check this by attempting to solve. So if I subtract 4x from both sides, my x's cancel. 4 minus 4, that's 0. So I get 10 on the left and 10 on the right. So 10 equals 10 is a true statement, and it's true no matter what x is because we have no x that's remaining. So That's why it's an identity equation. It's true all the time, no matter what x is. So our solution is all real numbers. So if we were to graph this equation, let me pull up the graph. I will turn these off. So the first one is y equals 2x plus 5. And then the second one, we have 2y equals 4x plus 10. You can see that it's right on top of the other graph. So since it's right on top, that means that they are identical equations. So the solution is all real numbers because they intersect everywhere because they're on top of each other. And you can see visually that they are identical equations because the second equation is just the first equation multiplied by 2. So they are the same equation. If you took the second equation and divided everything by 2, you would get the first equation. Now, the way that we write our solution is you could say they're all real numbers, you can put it in interval notation, but some textbooks will say, okay, we have an ordered pair x comma y where it needs to follow the equation y equals 2x plus 5. We're saying that, yes, there are infinite solutions, x comma y, but they need to be on this line. So that's what this is saying when we write our solution this way. It doesn't matter which equation you put in there after the bar just means where. But I usually put the one that's solved for y just in there. But it really doesn't matter. So now let's take a look at example 3. So again, these are both solved for y, so I'm going to set them equal to each other. So I have the left equation, 2x, the top equation is 2x plus 5, and it equals the bottom equation, which is 2x plus 10. So I'm going to solve for x, so I'm going to subtract 2x on both sides. So 2 minus 2 is 0. So again, the x's cancel again, and I have 5 equals 10. Well, that is a contradiction. That is not true. So that is a contradiction. And when you get a contradiction equation, that means that there is no solution because they don't intersect. So let's take a look at this graphically. And again, pull up Desmos. So I've got 2x plus 5 already in there. I reuse the same equation. And then y equals 2x plus 10. So you can see these are parallel lines. And parallel lines mean that they have the same slope, so they're never going to intersect. So if you notice that you have parallel lines, then you immediately know there's no solution because they cannot intersect, because that's the definition of being parallel. So this is why we learned what it means to have parallel lines or perpendicular lines. Here, you can see the slopes are the same because they both have a slope of 2. So that means that they are parallel lines. And parallel lines don't intersect. Thus, no solution. So as far as linear equations go, we've seen that we have 3 different types of solutions. We have one solution where there's an intersection. We have infinite solutions where they're the same exact equation. And then we have no solution where they don't intersect at all. And these are special for lines. If you're graphing something that's a line and something else, then generally you always have a solution. So I've got the same thing here. I'm going to just zoom in. So we've got the graphical interpretation of solutions. So number of solutions, and these are particular for linear equations. Unfortunately, it doesn't let me highlight while I'm zoomed in. So if you have exactly one solution, the 2 lines intersect at one point, which means the slopes of the 2 lines are not equal. They don't have the same slope. Then when you have infinite many solutions or no solutions, they either are identical lines or they are parallel, and the slopes for both of them are the same. The only way to tell the difference would be looking at their y-intercepts if they're slope-intercept form. So if they are equal, then the y-intercepts are the same. So that's if they're equal. And if they are not the same line, if they're parallel, their y-intercepts are different. So that's how you can tell by just looking at the equations in slope-intercept form. And that can save you a lot of work graphing or solving, because if you have the equations in slope-intercept form, you can look at it and determine how many solutions you have. And then if you determine, okay, they have different slopes, then you go and do the solving process. If not, then you can determine without even doing any solving how many solutions you have. So now let's take a look at the method of elimination. So a lot of people don't like elimination at first, but the more they do it, the more they tend to like it. I use elimination when I have equations that are in standard form where the x and the y are on the same side. If I don't have both my equations in that form, then I use substitution. So for me, it depends on what my equations look like. But a lot of people will just choose one method and do it. You can, if you like one method, if you like doing elimination and you want to do that all the time, that's fine. If you like substitution and you want to do that all the time, that's fine. It's just another method that you can use for solving. So here's how the method of elimination works. And this one involves a little more critical thinking, which is why I think most people don't like it from the very beginning. So first, you have to obtain coefficients for x or y that differ only in sign by multiplying all terms of one or both equations by suitably chosen coefficients. So here's what you're doing for elimination. You are trying to add the equations together in such a way that one of the variables will add to 0. In order to do that, one of the variables needs coefficients that are the same number and opposite in sign. A lot of times that it doesn't come like that, so you have to multiply the equations by something in order to make them have the same number opposite in signs so that they can be added and canceled out. We're allowed to do that because you're allowed to multiply both sides of an equation. If you wanted to, you could also divide both sides, but most people prefer multiplication. So we're basically artificially multiplying the equation by a number so that when we add, something cancels. That's the whole goal here. So once you multiply it so that you have something that's the same number opposite signs, then you add the equations together, and that variable that matches, that will disappear because, like, let's say you have a negative 2x and a 2x, that disappears. Then you solve the remaining equation, and then you back substitute. So you take your answer and you plug that into one of the other equations so you can get the other variable. And then, of course, you check your solutions. So here's example 4, and I'm going to show you how you can do it either way. You can either eliminate y and say, okay, I don't want y, I want to get rid of the y, or you can eliminate x and say, I'm going to get rid of x. You can do it either way, it really doesn't matter. So we have y minus 2x equals 5 and y plus x equals 2. If I add these equations right now, and let me just rewrite these. Whoops, that's an equal sign, y plus x equals 2. So if I add these equations, I get 2y minus x equals 7. And I still have x and y, and I haven't really made any progress. But the goal is when we add them, something disappears. So if you look at this, let's say I want to get rid of the y. So if I want to get rid of the y, I need the y's to have the same coefficient and be opposite in sign. Right now they both have a coefficient of 1, but they're the same sign. So I can multiply one of the equations, it doesn't matter which one, but I can multiply one of the equations by a negative so that they are opposite in sign. So I'm just showing my work up there, just showing that, okay, I'm going to multiply it by negative 1. So that would give me y minus 2x equals 5, and then negative y, and then I have to distribute my negative, that's a negative x. And I'm multiplying both sides here, so I'm also multiplying by a negative 1 on the right, and that equals negative 2. So I'm basically changing the signs of everything. Then I'm going to add them together. So y minus y is 0. That eliminates. We just eliminated y. Then I have minus 2x minus x, that's negative 3x. And 5 minus 2 is 3. So now I have an equation that's really easy to solve in x, and this is why I like using this method. So then all I have to do is divide by negative 3 on both sides, and I get x equals negative 1. Then what you would do is you would plug negative 1 back into your equation and solve for y to get your answer. Now, because we're also going to do the other method of eliminating, I'm not going to do that. I'm going to find y by eliminating x. So let's take a look at what we have. I'm going to erase. And so we have y plus x equals 2 is that second equation. I want my x's now. If I'm going to do this by eliminating x, I need them to have the same number. So the first equation has 2 in front of the x. The second one has a 1. I can multiply the second equation by 2 on both sides so that I can get a 2 in front of the x. So that would give me, I have y minus 2x equals 5, and then I get 2y plus 2x equals 4. And that's from taking that second equation and multiplying it by 2. Sometimes you have to multiply by a negative if they are both the same sign. Here they are already opposite in sign, they just didn't have the same numbers. So now I'm going to add these equations together. So I have y plus 2y, that's 3y. And then a negative 2x plus 2x is 0. So those cancel out. I just eliminated the x. And then 5 plus 4 is 9. So then I can divide both sides by 3, and I get y is equal to 3. And now I have just found both values. So now I have the solution. It is negative 1, 3. I could also get that by plugging in one of these into the equation. So I'll just do that in a different color here. I'll say, let's say I did the second way and I got rid of x and I had y equals 3. I can plug that into the first equation where y minus 2x equals 5. So that'd be 3 minus 2x equals 5. So I would subtract 3 from both sides. I get negative 2x equals 2. And you divide both sides by negative 2. X equals negative 1. And now you've gotten negative 1, 3. So it's essentially the same amount of work there. You're back substituting into the equation and then solving. So let's take a look at this on the graph so you can verify your answer. And so the first one here, so we have y minus 2x equals 5. That's the first equation. Oops, I thought I got rid of that one. And then the second one is y plus x equals 2. So you can see that they intersect, and then when I hover over it, I get negative 1, 3. So that is the correct answer. So you can verify your answers by graphing. So that is systems of equations in a nutshell. I showed you 3 problems for 3 examples of substitution method, 1 of elimination. When you go on to pre-calculus, if you have to go on to pre-calculus, you'll spend a whole week on these again. Well, you'll be looking at substitution and elimination again. And then the week after that, you'll be solving my matrices, which is also using elimination, but using something called a matrix. So it looks a little different, but it's the same process. So in a way, you'll be solving systems for 2 weeks in a row. Just one of them you'll be doing substitution and elimination, and then the second week you'll be using matrices. So that's it. That's all I have for you guys. If you have any questions, of course, you're welcome to email me. You can give me a call, send me a chat message, and I will be talking to you in the discussions and looking forward to having a great end of term.